All right, let's get right into it. Have you ever really thought about what a matrix is? I mean, beyond that thing you saw in math class. Because trust me, there's a whole other world hiding in there.
Yeah, on the surface, it's just a box of numbers, right? A simple grid. But then you hear it's the engine powering the modern world. Everything from crazy computer graphics to artificial intelligence. How in the world does a simple box of numbers do all that? Well, that's the big mystery we're going to unravel today.
Okay, so let's start with world number one. This is the matrix you probably remember from school. The historical view, where a matrix is basically just a box for your data. So, the textbook definition is pretty dry. It's a rectangular arrangement of numbers and rows and columns. But a better way to think about it, it's like a filing cabinet for numbers, super organized. Every number has its own spot, its own row and column, so you know exactly where to find it. And this thing didn't just pop into existence. Nah. It took like 100 years to cook. It all started back in the 1700s and 1800s with guys like Kramer and Gauss using similar ideas to solve equations. But the name, that came from J.J. Sylvester in 1848. He called it a matrix, which is Latin for womb, because he saw it as this thing that gives birth to other mathematical ideas. Pretty cool, right? And then Arthur Cayley came along and really kicked things into high gear by creating matrix algebra. That was the real game changer.
So, its first big job was tackling those, super annoying systems of linear equations. The genius was that you could just pull out all the numbers, the coefficients, stick them in this grid, and bam, suddenly this messy problem looks clean and simple. It was all about organization.
All right, so that's world number one, the matrix as a static box. But now let's jump into the second world. This is where things get really exciting. This is where the matrix stops being a container and becomes an engine. A machine for movement. And look, I had to use this quote, right? Because to understand this next part, you really do have to shift your whole perspective. You gotta stop seeing that boring static box of numbers. The real way to think about a matrix is as a function, a transformation. It's not a noun, it's a verb. It does stuff. It takes a point in space, we call that a vector, and it moves it somewhere else. It's a set of instructions for a journey. Now, it's not just any kind of movement. A matrix describes something very specific, a linear transformation. And what does that mean? It just means two simple things. One, all the grid lines of space stay parallel and evenly spaced. They can stretch, they can rotate, but they never get curvy. And two, the center of space, the origin, it stays locked right in place. Okay, so this is the big question, right? How on earth does that simple box of numbers we talked about before hold all the instructions for this complex, elegant dance of space? Well, the secret is all about tracking two very important little vectors. They're called the basis vectors. In a flat 2D world, we've got I hat, which is just a little arrow pointing one step to the right, and j hat, an arrow pointing one step up. Think of them as the fundamental building blocks of our entire coordinate system. Okay, here's where the magic happens. Because the transformation is linear, you only need to know one thing. Where do those two little guys, I hat and j hat, end up? If you know where they land, you know where every single other point in space lands. The entire grid has to move along with them, perfectly in sync, keeping all the lines parallel. And this is the big reveal, the aha moment that ties it all together. How does the box of numbers tell you where they land? It's so simple. It's brilliant. The columns of the matrix are their landing coordinates. The first column tells you exactly where I hat ends up. The second column tells you exactly where j hat ends up. That's it. The whole instruction manual is right there in the columns. That's the whole secret right there. A matrix just tells you where the basis vectors go. This one beautiful idea is like the Rosetta Stone connecting our two worlds. It's the bridge between the static box of numbers and the dynamic engine of movement. So, now that we've bridged that gap, let's see what this dual identity unleashes in the real world. This is where the power really comes from. I mean, just look at this stuff. Computer graphics, every time you see a character run or an object rotate in a video game, that's matrices at work. Artificial intelligence, the neural networks powering AI, are basically just massive chains of matrix calculations. They're everywhere, from mapping out social networks to describing the physics of quantum computing. Let's take a super simple example from graphics. See this matrix here? It's got numbers only on the diagonal. This little guy represents a scaling transformation. It's a set of instructions that says, stretch space. If you apply this to a 3D model, it'll make it taller or wider. It's an incredibly simple and fast way to code these kinds of changes. And that's the key, you see. Real-world applications use both identities of the matrix. They use it as the box to store the instructions for a transformation in a nice, neat package. And then they use it as the engine to actually apply that transformation to millions of data points, whether that's the pixels in an image or the nodes in a network.
Okay, so let's pull everything together for one final thought. We started with what seemed like a really simple, almost boring box of numbers. But where we've ended up is, well, it's way more profound. A matrix isn't just an object. It's a language. It's a way to describe relationships, and most importantly, a way to describe change itself.
So, the next time you see one of these, don't just see a grid of numbers. See the instructions inside. See the movement. See the transformation just waiting to happen. It's honestly a perfect example of how a simple shift in perspective can unlock a whole new universe of understanding. And it really makes you wonder, right? What other simple things that we see every day are hiding a much deeper, more incredible reality?